it's going ahead. Okay, so yeah, why don't you tell me a little bit the important research? Maybe do you know of some pretty big ones that they're working on right now?
Yeah, and we have a faculty member in the School of Biological Sciences, Joanna Kelly. I mean, she's kind of doing some stuff where she looks at how different organisms adapt to various environments and stuff like that. And again, one of the things she's doing is related to this toxic gas, hydrogen sulfide, because although we say it's toxic, she has found in some areas in the Caribbean, there are some lakes where there are some fish living in these lakes which are full of hydrogen sulfide. So that means these fish have adapted to those conditions and they could survive in those conditions. So one of the things she's trying to do is trying to take the fish from the lake and then fish from a lake where you don't have this toxic gas and try to look at their genome and try to see how they have adapted to that harsh conditions, because then that will help us to understand how this hydrogen sulfide can be used in humans also, so that they can be therapeutic. So I'm just giving you kind of brief sketches of things, okay?
That's fine.
And then there's another person, Elisa Schwartz. I mean, she's in mathematics and also in the School of Biological Sciences. She has a kind of joint position in two different departments, and so what she does is mathematical modeling of kind of problems that can be health related and biology or ecology related. So one of the interesting problems she worked on, I think it's here, I can show you. Okay, you can look at the paper at the bottom there. So when there was this H1N1 pandemic, that swine flu pandemic that happened in like 2009 or something, here in Pullman, Washington State University, there were a lot of people who were getting sick. So the student health center was getting a lot of students going in there who they suspected may have been infected by H1N1. So she did a paper on that, working with students, collecting the data from the student health center and try to analyze that to see what kind of pandemic was it, in a local community, in a rural community like Pullman. So that's kind of interesting. That's that kind of modeling can be used even for other problems, other diseases. When they hit a small town or something like that.
Right. Yeah. So this kind of problem could be used possibly in the future with another sickness.
That's fine. Yeah.
Right.
Yeah.
Okay. So
whenever people talk about some new diseases coming up or something like that, it doesn't have to be new disease. I mean, because you see in the newspapers and the media now, some of these older diseases that have been eradicated, they're coming back, like whooping cough and stuff like that. So when they come back, they are like a new disease. The reason is the people have been not exposed to them for a long time because people thought they were eradicated, and so the human system, the immune system, when they encounter these viruses, they think there's something new. They don't know how to handle it.
Right.
Okay.
And then this kind of research could help us to attack those problems when they come about.
Right. And also even, not just here, like for example in Africa, I don't know whether you saw that in the recent times, Ebola virus has come up. So, when you have a mathematical model, that kind of talks about, how the infection spread among people and stuff like that. So looking at the outcome of the model, you can make predictions and you can make decisions on trying to control those kind of stuff.
Right. That is really interesting.
Yeah, there's another thing, this is me doing, I do this, I have a class, I can give you this too. I do this class in the fall. It's an honors class in the honors college. So you can see the title of the class is Science as a Way of Knowing. But one of the things, I talk about two different topics there. One is about spread of infections, and the other one is about population growth. So again, the spread of infection, we talk about, let's take Pullman, a small town, right? And like H1N1, there's a new disease, let us say, is going to come or whatever. So how many people you need to vaccinate so that it is not going to be a small epidemic in Pullman? So you can determine all this in a quantitative way using mathematical model.
Are you guys in this class, are you just looking at kind of rural areas like Pullman? Are you looking
No,
at
it's in that class it's kind of very general, but I kind of, because the model you develop is very general, it can be applied anywhere. Okay. So, I can show you something if you're interested. Also, as part of the class, working with the global campus, we even developed a YouTube video that's on the public domain. Anybody can go and look at it. Let me see that.